Hello, welcome to this introductory video about London dispersion forces. Today, we will be reviewing the basics of London dispersion forces, which can be shortened to LDFs. LDFs have nothing to do with the City of London. They are actually named after physicist Fritz London, who studied the bonds between molecules. We will start by defining what an LDF is. LDFs are temporary attractions between two molecules or atoms. This attraction is the result of instantaneous dipoles. Instantaneous dipoles are caused by the changing positions of electrons in molecules. Electrons are negatively charged subatomic particles that move around the positively charged nucleus of an atom. Instantaneous dipoles are caused when electrons, which are in constant motion, are more concentrated on one side of the molecule. The electron's position is temporary. Because the negatively charged electrons are concentrated on one side of the molecule, a temporary negative and positive area of the molecule form. This is known as an instantaneous dipole and results in LDFs. LDFs are formed when positive and negative areas of different molecules are attracted to each other. LDFs are the weakest intermolecular force. Other intermolecular forces include dipole-dipole forces, hydrogen bonds, and ion-dipole forces. LDFs occur between all molecules. Both polar and nonpolar molecules can form LDFs. Polar molecules have unevenly distributed electrons that can form other intermolecular forces beyond LDFs. One common example is H2O, or water, which forms hydrogen bonds. Nonpolar molecules have an even distribution of electrons or have a symmetrical Lewis diagram. Examples of nonpolar molecules include carbon dioxide and chlorine. Larger molecules form stronger LDFs. This is because molecules with larger radii have more electrons. Electrons near the outside of the molecule are not as strongly attracted to the positively charged nucleus and can more easily form instantaneous dipoles. The ability for the electrons to more easily form instantaneous dipoles is called polarizability. For example, the molecule C2H6 is more polarizable than CH4. Therefore, C2H6 forms stronger LDFs. The shape of a molecule also affects its polarizability. Molecules with linear shapes have more areas that can come into close contact with surrounding molecules than molecules with a cylindrical shape. This allows them to form more LDFs and therefore have stronger bonds. Now let's do some practice. Which of the following molecules would exhibit the strongest LDFs? If you need more time to answer the question, pause the screen. The correct answer is the last one, because the linear shape and large size allows the molecule to form the strongest LDFs. For our next question, which of the following statements about LDFs is incorrect? If you need more time to answer the question, pause the video now. The answer is C. Molecules that are more polarizable have weaker LDFs. This is the answer because molecules that are more polarizable have more electrons and therefore have stronger LDFs. Thank you for listening to my presentation about London dispersion forces. I hope you learned something, and if you have any more questions, be sure to check out other videos.